Hello everyone, today we are going to go over some blind 75 C++, and apologies if I'm not on Leetcode right now. Leetcode is just currently down as of the moment, and just what I'm currently doing is just doing everything local for the most part. And if you are also interested at the same time in knowing how to do this locally, just in case you have a better IDE and understanding with the interface and get the foundation, which is something I highly recommend in this, what you can do is just copy and paste your solution over here. And then since you have your parameters already set in place with string, s, and k, for example, for our following problem up here, what you're going to have to do is first create an instance of solution that can be called right over here. Then you set up your parameters of k and your string, the other string, and then your k. And then you are going to be returning exactly what they are ultimately asking for. And then I'm going to break down the question over what we need pretty soon. So they will call upon sol solution, character replacement is the method, character replacement is the method, your parameter s which is string, k, and k as well, and then you output your result over here and return 0 as inside your main. But this is just where we will be writing our solution to start. So to be able to go over the question of longest repeating character replacement, you are given a string s and an integer of k. Now, before we do anything else, I'm just going to have our 4 questions, our input, what data structure / algorithm / technique we're going to use, what to do with the data, and then what our output is going to be. I'll just put down output. And I just put return -1 as just sort of a placeholder so the IDE doesn't suddenly freak out. And yes, you can do this in Xcode as well. It's pretty good. And just have the option for C++. So anyway, we have our given input, which is a string and integer k. And I'm just going to put in the rest of the comments over here to start. Gets further out. Alright, you're given a string as an integer k. You can choose any character of the string and change this into other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring container, the same letter you can get after performing the above operations. Okay, so just to give a breakdown of what we're doing, so it looks like that will be returning the length of the longest substring containing the same letter you can get after performing the above operations. Now, same amount. So, in particular, by what they mean to be able to start is that we just need to return the maximum length of the substring that can be performed by replacing as many most characters. So, going over example 1. We have a given input of string a, b, and k of 2. Now, and then the output of this is 4, and the reason being, as they state, is replace the 2 a's with 2 b's and vice versa, as in how many times can you replace the number of characters inside of our given string. And in this case, for example, a, b, it's asking us to replace one of the characters, and in this output it said we can replace it 4 times, such as replace the 1a in the middle of b and form a, b, a with the longest substring of being b with the longest repeating character. So after we replace the character, we would have to see what the longest substring would be after we replace, for instance, 2 characters, and then we could have the longest output accordingly as a result from replacing the 2 characters. Okay, so so k represents the number of characters we can replace, and then we are again returning the length of the longest substring containing the same letter you can perform. This was confusing, I apologize in the output. So it looks like they're returning the length of the longest substring after replacing the k number of characters. Okay, right over here. And the technique that we would do for strings in C++, in this case, for this one, would be the sliding window technique, where it's unlike binary search and then two-pointer, where binary search is more of a divide and conquer, and you have three different variables of a middle, low, and high end. And in two-pointers, you just have, literally, as the name implies, two pointers, your left and your right parts, and this would be helpful for substrings. But in this case, for sliding window, we have three variables, which are 2 pointers and 1 max length, where the max length will change. And then with our sliding window, we can use any data structure we want. In this case, we're going to use an array to keep track of all the characters visited in the string to start. So, and then what we'll be doing with our following solution is that we will adjust the window to maximize the length of our substring with the most repeating characters after replacing the k number of characters in our string. We change the size of the array depending on if there are repeated characters. Meaning, if there are repeating characters, we continue. If not, we stop the size of the array. Alright, just to go further in depth of what we need to do with the following data, just given the steps. Alright. 1. We will initialize our 2 pointers and max length. We will initialize an array to keep track of the frequency of characters in the substring which are repeating. And then what we will do is that we are going to loop through the data and expand upon the relationships of our 3 pointers, but starting with the right pointer and our length of string. Then what we will do is then increment the frequency of the right character while going up the string, because if we look at our given array, the rightmost, we are still going up on the right side. And what we will do is we will update the max frequency in the current substring by creating a function to get the count of our max frequency. Then if the length of the current substring minus the maximum frequency exceeds k, decrement the frequency of the character at the left pointer and move the left pointer as we are moving up our array. And then we will update the max length, not the frequency. We first just to be able to clarify in step 5 is that when we mean by our max frequency, we also mean our array, which represents the frequency. And for step 7, we will update the maximum length of the substring and checking the difference using max from the STL library to compare the max length and characters of the 2 pointers. And then finally what we're going to be outputting over here is going to be returning the max length of the substring, which can be formed by replacing k most characters. Alright, now just to be able to give a rundown on what we have done, our input, we're given a string and an integer, and k represents the number of characters we can replace. What data structure / algorithm / technique we're going to use. We're going to use a sliding window technique. We have 3 variables, 2 pointers, and 1 max length. The max length will change, and we will use an array to keep track of all the strings called max frequency. And the steps we will do is that we will initialize a 2 pointer and max length. We will initialize an array to keep track of the frequency of the characters in the substring which are repeating. Then loop through the array and expand upon the relationships of our 3 pointers, but starting with the right pointer and our length of string. Increment the frequency of the right character while going up the string because moving the array to the right side, and then we're going to update our max frequency of our array. Max frequency of our array in the current substring by creating a function to get the count of our max frequency, which is also our array. Then, if the length of the current substring minus the maximum frequency exceeds k, decrement the frequency of the character at the left pointer and move the left pointer as we are moving up the array. And we will update the maximum length of the substring and check in the difference using max from the STL library to compare the max length of the characters of the 2 pointers. So now just giving a breakdown, and then ultimately we're just returning the max length. I just pretty much just want to make sure the notes are all clear. Alright, so now just to be able to go forward, so we're going to have our right side, which is going to be our count, and left side would be that, and then int max length. Going to be 0, and then we're going to have our array, which is our max frequency. And since one of the constraints, luckily, is the 26 characters, 6 characters of the alphabet, so which should be a vector times int of frequency, which is also called upon from the STL library of 0/26, or no, 26 to 0. There we go, and then we already know. Apologies on that. Alright. Then now we're gonna put in a while loop. We are on step 3 right now. While the right is less than s dot length as indicated by the string, and then increment the right side. We will increment the array with our right pointer, so that means frequency, which is our array, is going to be incremented with our right. Yep, that's right. And then we're going to update our max frequency and max frequency with our array. Get max frequency. We're going to create a function for this. What we're doing is that this is how we are going to create a sub-function over here. Vector int and frequency over here. Max freq is going to be initialized over here, and for int count frequency max freq equal max freq count, return max frequency over here. So this is how we will be updating our frequency of our given count that we would have. Make sure you spell everything correctly. Okay, there we go. Going back in a while loop after we just created that function, now we are going to check the length of the current substring minus the max frequency if it exceeds k, because we can only change one of the characters k number of times. We can change only a certain amount of characters k number of times. Minus left plus 1 minus the max frequency, which that should represent the length within our given array that we are also incrementing at the same time. And then if it's less than a left minus a dot left would also increase. We would then move our following sliding window up our given array from the left pointer, and therefore it would actually be decremented because we've already kept track of it by using the right. As if, imagine we're starting from the beginning, like this is the right immediately, then we keep going, and then we can actually change one of the characters accordingly. So we can change this one and then that one as well as we're moving up, and we are expanding said window, because expanding the window is starting from the right all the way to the left. Alright. After we have done that, we will update the max length as well. Max length, max, by making a comparison between right minus left plus 1 as it's moving up the array, and then we're going to increment right as we're expanding the entire window altogether. Alright, that should be good. And then finally what we will be doing is that we will be returning our max length. We just kept the -1 as sort of a placeholder right over here. In the worst case scenario, it would actually return 0 because we've already decided that, oh yeah, it's not really there to start. So to test this out, in our given example, I have already AAB A, B, B, A with our K of 1, and we are supposed to have an expected output of 4 to start. And I'm just going to make sure this is all right, so I'm just going to press play. The result is 4. There we go. Okay, as highlighted by the example up here. Oh wait, this is 2. Yes, right here, this example over here, that makes sense. A, B, B, A, it was example 2, and the output is 4. Now let's do the same thing if we were to have 2. and have the same string from example 1. Supposed to have an expected output of 4. There we go. All right. And now just give a rundown on breakdown of the following time and space complexity. The time complexity for our following solution is going to be O of n, where n is referring to the size of our given string, and therefore if the string increases, the time of a program also increases as well, so it's constant time. However, what's pretty efficient about this, given the fact that we're just using an array to start, and it's set to a fixed size of 26, we're not storing up anything else, we're just scanning, which is pretty useful for strings, especially if you're working with characters and the alphabet as well, which are just 26 characters. It's just going to be linear, which is pretty unique, because even though we're using a data structure, we're not storing necessarily everything. We're instead scanning throughout our entire array, which will actually make it very efficient to start with in terms of space complexity. So yeah, this is our solution over here. I'm just going to put the pseudocode up here. Start. There we go. So again, just give them the whole space and time complexity. The space complexity is linear because we have just 26 characters to start that we're just scanning through after we created our given array, which would be a vector in this case, which can be treated as arrays. And the fact that we're just scanning throughout the entire string, and our array has just 26 of the characters that we're just scanning throughout the rest of our string, we will have a space complexity of linear, but again, time complexity is constant, O of n. All right, so that was longest repeating character replacement. Thank you again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any questions, feel free to put them in the comments section. As always, take care. Cheers. Bye-bye.